Why is debugging eventually consistent NoSQL so challenging? Imagine trying to fix a puzzle where some pieces are missing or out of place, but you can't see the whole picture at once. That's what debugging in an eventually consistent NoSQL database feels like. These databases are designed to keep your system running smoothly even when parts of it fail or are slow. But that comes with a twist. When you write data, it doesn't instantly show up everywhere. Instead, updates spread out over time across multiple servers. This means some parts of your database might still have old data while others have the latest. This delay makes it tricky to figure out what went wrong. If your application reads outdated data, it might look like a bug or inconsistency. But in reality, it's just a temporary state. This is especially confusing when trying to reproduce bugs. You might see different data at different times, making it hard to pin down the cause. One big reason for this challenge is that most NoSQL databases do not support full ACID properties. That means they don't guarantee that all related data updates happen together or are immediately consistent. Without these guarantees, your application has to handle conflicts and outdated information on its own. This adds extra layers of complexity to debugging. Another issue is network partitions or delays. When parts of the system can't talk to each other, some nodes might hold outdated data. During these times, users might see conflicting or stale information. Debugging these issues requires understanding how distributed systems work and how data propagates. It's not just about fixing code but also about understanding system behavior under failure conditions. Caching layers also make debugging harder. If your application caches data for faster access, stale cache data can mislead you into thinking there's a bug. Synchronizing cache invalidation with the database's eventual consistency is a delicate task. If not handled properly, it leads to confusing inconsistencies. Detecting when data is out of sync is another challenge. Developers need to build mechanisms to identify and handle these situations. Whether that means retrying operations, merging conflicting updates, or alerting users, each step adds complexity. It's not just about fixing bugs but also designing systems that can recover gracefully from inconsistencies. Finally, how you design your data schema and application logic impacts debugging. Poorly planned models can increase conflicts or make reconciliation harder. Developers need to think carefully about how data flows and how to minimize conflicts from the start. All these factors mean debugging in an eventually consistent NoSQL environment requires more planning, testing, and monitoring. It's about building systems that can handle temporary inconsistencies without breaking. This approach shifts some responsibility from the database to the application, demanding new patterns and tools. While it's more complex, it allows for highly scalable and available systems that can serve millions of users efficiently.